Hello everyone, welcome back to Calculus BC. We're in lesson number 36 where we're talking about logistic growth. And we've already did an example about population and now we're going to talk about some shrimp. So let's see, I've already written the equations down that we used in the first video. So these are just really nice equations for you guys to know. So the question says a biologist stocks a shrimp farm pond with 1,000 shrimp. The number of shrimp doubles in 1 year, and the pond has a carrying capacity of 10,000. How long does it take the population to reach 99% of the population's capacity? So the first thing we want to do is say, well, what do we know over here? So we know that the initial position of our shrimp is 1,000. So we've automatically popped in 1,000 shrimp there. We also know that our carrying capacity is going to be 10,000. So just from this alone, guys, we can actually figure out what our A is. Our A is in our equation. And we already know what our L is, so we can find our A. So A is going to be equal to our carrying capacity minus our initial population, all over our initial population. A is going to be equal to 10,000 minus 1,000, which is 9,000, all over 1,000, which is going to give us 9. So A is going to be actually equal to 9. And so we have now what A is. So we have to find what our K value is. But the other thing is, it says how long does it take for the population to reach 99% of the pond's capacity? Well, we want to do 99% of 10,000. Well, we would just multiply 10,000 by 0.99, and you guys are going to guess it, or you probably don't even need your calculator for this. We're trying to figure out this right here. And so what we need to do is also realize that the number of shrimp doubles in 1 year. So that's another thing that we haven't used yet. So when we look at in 1 year, so P of 1, we're going to look at 2,000. And this is going to be how we're going to get our K value. And we did this very similarly in exponential growth. So then when I know that T is equal to 1, when T is equal to 1, my P of T is going to be equal to, so when T is equal to 1, my P of T, which is P of 1, is going to be equal to 2,000. So I can go ahead and say 2,000 is going to be equal to our carrying capacity, which is going to be 10,000, all over 1 plus 9, right? A is 9, e to the k times 1. So just like before, we're going to go ahead and cross multiply. So we're going to do 1 times 2,000, which is going to be 2,000, plus 2,000 times 9 is going to be 18,000, e to the k, and that's going to be equal to 10,000. Well, 10,000 minus 2,000 is going to be 8,000, and then we're going to go ahead and divide this by 18,000. And so we're going to take the natural log of both sides, so the natural log of e to the k will just be k. So k would be equal to the natural log of 8 over 18. And so k is going to be equal to negative 0.811. So that's going to be the k value that we have here. And so usually the k value when you do your problem set is going to be correct. It's going to automatically be negative. So let's go ahead and put down what our k value is over here in our picture too. So k is going to be equal to negative 0.811. And so now we have all the information that we need to solve our problem. And let's go ahead and do that by now putting things together. So we have the L, we have the A, and now we have the K. So we want to say what time, so we want to know P of T is equal to 9,900, and we want to know what the T is. So what T value is this? So 900, I keep saying that, 9,900 is going to be equal to our carrying capacity, which is 10,000, all over 1 plus 9e to the negative 0.811 t. And I know this gets pretty tedious, guys, but the same thing. We're going to go ahead and multiply by 9,900. And then 9 times 9,900 is 89,100, e to the negative 0.811t. And we set that equal to 10,000. So we know now that we're supposed to subtract 9,900 and divide by 89,100. So I'm going to go ahead and pause that and write down what that is. So using my calculator to do this operation I just told you guys about, we have e to the negative 0.811t is equal to 1 over 891. So adding the natural log to both sides, the left-hand side will be left with negative 0.811t is equal to the natural log of 1 over 891. And then t is going to be equal to this value right here divided by negative 0.811. And so we're going to get that the time is equal to, the time is 8.375 years. So it's going to take 8.375 years to get our population of our pond to 99% of the pond's capacity. So as you guys can see in the problem, they do a good job of giving you guys enough information that you can solve for certain pieces of our equation. Our whole goal really is to get the equation where we have our carrying capacity, our A value, and our K value. And so that's really what we need to do. We're going to do one more example. So one of the classic examples that's not population for this particular example with logistic growth is talking about rumors and how rumors can spread pretty quickly. So you guys can see in the wording here that, when very few people know the secret, and they start telling people. And then and so we have tellers and hearers. And so once you're told, you become a teller. And so the more people learn, the faster it grows. It gets really fast. And then after a while, so many people know that the news is going to start spreading slower and slower and slower. So very few people know, then everyone starts talking about it, and then, only a few people don't know yet, so it comes back like this. So this is a classic logistic growth graph. It's really awesome. I will tell you guys again, based in the first video, that it's going to have its fastest speed right here in the very middle. So let's actually read the question and see what's going on with this. So Bulldog Central High has 1,300 students. There are 4 Honor Society officers, Brian, Scott, Isaac, and Tara, and 21 senior other members of Honor Society spread on day 1 that Mr. Woolgardner is to become principal. A day later, so 1 day later, 62 students of the 1,300 know the rumor. What's happening over 10 days? So how many students are going to figure this secret out based on this information in 10 days? Well, first thing is, here are equations that I wrote for you guys here. And so what do we know from the equation, or from the words? So we know that our carrying capacity is the maximum amount of students, right? So we have 1,300 students. That's how many students are actually in the school. So that's going to be our carrying capacity. We know that initially, our population says we have 4 Honor Society officers plus 21 senior members. So on day 0. So we know that 4 plus 21 is 25. So we know that P of 0 is equal to 25. We know that a day later, at time equals 1, so P equals 1, I have 62 people know the rumor. We have enough information now to find A, find K, and then figure out what's happening at time equals 10. So first thing we're going to do is we're going to use our equation that A is equal to our carrying capacity, which is 1,300, minus our initial population, in this case 25 people over 25, and that's going to give us that A is going to be 51. And so we would use our calculator for this, cross multiply, whatever you want to do, but this is how we would solve the problem. And so we're going to get that this is going to be 51. So we have that. The next thing we're going to do is we're going to find the K. And so we know that P of 1, which is going to be equal to 62, is going to be equal to our carrying capacity, which again is 1,300. It's going to be 1 over 1 plus 51, e to the k, and then again t is going to be equal to 1. So you guys have seen this so many times before, so I'm just going to go ahead and write out that 1,300 is going to be equal to 62 plus 3,162 e to the k. E to the k is going to be equal to 0.3915. And so our k is going to be negative 0.937. If you do the math correctly, then your k value will end up being negative. So sometimes people say, well, let's just make the k negative here. it's totally fine. Then you'll get a positive answer here, but let it just work its course, and you'll be able to figure it out. But all I did, ladies and gentlemen, like I said, I've done this several times now in these videos, is cross multiply, right? Cross multiply, subtract the 62, divide by this number, take the natural log of both sides, bam, there's your k. So that's really what we need to do to find that problem. And then the last thing we want to know is what our question's asking us. So the question is asking us what's happening over 10 days. So what is P of 10? Actually, not T. What is P of 10? So P of 10. What is that value? Well, let's go ahead and plug it in. So P of 10 is going to be equal to 1,300. So how many students know this rumor after 10 days? We're going to do 1 plus our A value is 51. We're going to do E, our K value is negative 0.937, and then our T is going to be equal to 10. And so when you do the math for all of this, when you actually use your calculator, because this is a calculator question, you're going to get that our P of 10 is going to be equal to 1,294. So I want you guys to think about that for a second. That's actually kind of crazy. This represents students. This represents students. So this question's saying that on the 10th day, every student in this school, based on this formula, is going to know about this secret, if it is even a secret, except for 6 students. So I don't know what's going on with those 6 students, but that's the idea of what's happening. So it's actually very interesting for that particular problem. So that's all I have for you guys for the video. I hope this makes sense. We're going to come back and show you guys some multiple choice questions using logistic growth. So I will see you guys in your next video.